take the seven-sided form and you put it into minimum surfaces, which is a bubble, it looks like that. So now we have an organic shape that's based on a lawful process based on minimum surfaces. Okay. So if I take this form and I put this into minimum surfaces, it looks like this. And if I put these two together, it's the thickness of the muscles. I measured it. And this is, of course, what happens to this form when it spins. It looks like this. This is the vortex. All right, so I had to put this into projective geometry. This is three-dimensional projective geometry that I'm going to show you next. And it's a seven-sided form. And what I found out is, here's the seven-sided form, that if I take a cone, okay, and I put it in here like this, see, here's the circle that's twice as big as that one again, 2 to 1. If I put this through here, I found out that I can come right to the middle. It comes to the, that's why I cut this out, so you could see that it comes to the point. Okay, I found out that this cone is 22.5 degrees. It's the same cone, I just cut it. Okay, I found out that if I take this on the outside, all the corners hit perfect. And the inside is parallel. So that means that this and this are coming from the same degree, which is 22.5. And if I put a cone around this, it's 45. 2 to 1. This is 45 degrees, this is 22.5. So I wanted to find out what all that meant. And I wanted to know how that worked. So what I did was I took a piece of plastic, and this is known as a line. This is the plane. I want to know how this works. So I put lines on here because I was doing projective geometry. And what I did is I put a red line here where I split it in half. And now I can take this into a cone and find out what size it is. Okay, so I spread this around here. This is not in the books. I spread this around here like this. You see, one of the things we have to be careful about using Rudolf Steiner is that we have to make sure that if we're going to quote him, we need to back him up with something we found. If we just quote him, then we're just repeaters. We read, repeat. That's over. We can't do that anymore. We can't just make book reports on his lectures. And come and give a lecture on lecture 3, 1921 or something. No, we have to start now, not copying him, but backing him up. Oh, anyway, if I bring this around like this until the red lines lined up, I know I have two cones here. They're the same size. Let me get it right. So that I got two cones. And what happens is all the lines become curves. Yeah, that's really weird. But it won't fit in here. It's still too big. So I'm going to go take it into three cones. And I just take it around until the lines are again, and I'll show you where I get it lined up, when the lines are lined up. And what happens is that it turns into all triangles. And there's root 3. It still doesn't fit. Won't go in there. I still don't have it. So I got to do it again. So now this time I'm going to get 4 cones. So I turn it around until I get 4 cones and get those lines just straight up, okay, and it turns all squares. 4 cones turns into squares. 3 cones turns into 3 triangles. That's amazing. Well, it still won't go in. It's still too wide. It won't go all the way to the tip. So I had to go 4.5 before it goes in, and it goes into chaos. And what I mean to the chaos is going this way, and it's going this way, and it's going this way. Now, it didn't do that before, but it fits. Okay. So that helped me with this next problem that has never been solved. This problem has never been solved by anybody. And some big people, Lawrence Edwards worked on this, Dr. Pettigrew worked on this. They haven't found the answer. So I looked at this drawing for, I would say, 3 months, trying to understand why the layers of the heart start out going down, and after you peel the layers off, they're going up. Now that's a reversal, that's air. Okay, remember this form is between warmth and air. So this form is definitely a vortex, and what's happening is it's vortexing in like this, and it's reaching a neutral spot and then reversing. So I'll show you how that is. If you start out this way, okay, you can see that the next layer that he peels off, he was a doctor that did this, and then the next layer was at a different angle, and you could see here this line is that the muscles go inside this part. Okay, so you know it's being tucked in just like I showed you. It's a cone going like this. Okay, and then in the middle part, it gets fairly horizontal. Okay, and then it does its reversal. Okay, so how is that possible to create that movement? All right, now they say there's 8 drawings, there are 8 layers. So let me go back here to, I don't have any lines. Okay, I knew that the cone that I could put in here only had 4.5 turns. But I'm going to need at least 8. So what I did is I went back to this. Remember this one? Yeah. So, you know, it's a duality. And there's a balance. Okay, so what I decided to do was to put 2 of these together. So I did. Just took some paper. I drew these lines on here like they had them. And what I did was, see how I glued them? I just taped them together. That's really a cool form. But anyway, what I did is I taped them together. I didn't tape them, you know, right in the middle. So it's 2 full cones, just like this one. There are 2 of these that I have here I'm holding, taped together on the red line. So what I need to do is to find a paper clip. Oh, there's one. So I took these here and I put them together so that it would be at 22.5 degrees. Now they have to be at 22.5 degrees or this won't work. Now that's what's amazing, is that the inside of this form is 22.5 degrees. So you have to check it and make sure that you're accurate, that that is really 22.5. And I did. Then what I did the same thing on this end. I put this into a cone, making sure that it's 22.5 degrees, just like the other end. Put this in here. Make sure it's right. So then what I started to do, I said, okay, I'm going to roll this up. So I rolled it up. And I rolled it up until it got to the midpoint, where I scotch taped it together. I have to get this a little tighter here. I rolled it to the scotch tape. That's where I taped them together. Okay, so then I rolled up this one. I figured this is what's going on here. And I rolled it up. And of course it turned into 4.5 cones, just like this one. But the problem is that, now what? No, that doesn't work. I'm stuck right where I glued it together with the scotch tape, which was right there. Follow me? Doesn't work. So I studied and studied this, and I realized, well, why don't I just use what I have here and take this one and wrap it around this one? Oh, I did. And I kept wrapping it around, and now I came to where I couldn't go any further. Now I've got about 7.5 turns, 8 turns here, and 1 turn here. That's because this is the other ventricle. So if I show you the original one, which this one here, this is why it has that form. And of course, this thickness right here is the thickness of the layers of the heart. So, but my main thing was that I wanted to find out where this was. So I got some okay things I got to put on here. So what's happening is that the heart muscles went this way, okay? So as I unravel this, okay, you can see that they're starting to get straight across horizontally, and now they're starting to go back up in the other direction, just like the heart. All the way up. This is the duality of the heart, okay? This is the same as the Visakha that we first started doing here. All right. That rocks. All right, so what I did was I wanted to know when I put these both together, I was trying to learn how they work together. So here's the middle form I told you, and the outside form, and I found out that I can move the geometry. This is what the heart does. The heart moves just like this on the outside. But the inside doesn't do that like I'm showing you. It spins. And so what I did was I figured out how to make the inside bit spin and the outside do what it's doing. And this is broken. But it does work. Got broken. Though I could open it up like this. See how they both move? But the inside I could spin. And I'll try to spin it even though this is broken. I'll try to spin it. And there's the spin. The heart spins at 40 degrees. And then it empties. So it fills at 40 degrees and empties at 40 degrees. And where it does that is in less than 1 second. Exactly where it is 0.36. 36 degrees. Again, the 36 degrees comes up. This form right here, this angle here is 36 degrees. Perfect. This is 72, which is twice, 2 to 1. Okay. I'm going to show you a few more things up here. I found out that, that this form has a cube in it. Has a cube right in the middle. And this thing broke down, so I can't show you that. But just in case, I got it. I got the real one in my suitcase. But I'm going to shut this down and find out and see if I can start this up again and see if I can bring it up. So I've shut it down. Is it showing on the screen? All this I'm doing? It's not? No. Oh, you know what's wrong? This computer isn't plugged in. Oh. This is not plugged in. It's run down to 4%. So I bought this one. Maybe this doesn't work here. It's supposed to be an adapter. Ah, it's working now. All right, let's just give it a few minutes to run up. And then when we do that, we'll get it again. And I'll be able to show you what happens when this spins. Rudolf Steiner talks about a fifth chamber. I've found it. There's a fifth chamber in the human heart that's going to happen in the future. I know where it is. I can show you geometrically. But it hasn't come in yet because, who knows? I have some idea why, but it's not here yet. It's up to 5% already. Okay, so just in case I got that form. And I could bring it out if you want to see it. But to think that there's a perfect cube in this form is just too much. I cannot believe it. But there is. Here is the, let's see if we can get this running. Here is the heart and minimum surfaces. Yeah, all right, we got it. We're back online. Now,